Ready, guys? What questions will we have a look at now? Lucas, could you pass my book back up, please?
Oh, yes.
Maybe you could just share for a moment.
Okay. Yeah, that's okay. I have it written there.
Grant. Right, where will we start for the tutorial? What do we need to have a look at to begin with? Projectiles. Okie dokie. What question? Okay. 6. Let's do that one. Okay, let's have a look at 6. Where did I put my pen down? Okay. Oh, there. Sorry. No. Right. Let me just check something here. Sorry, 1 sec. No. I'll just. Whoa. Sorry, I'm being stupid right now. Just a sec. A dog with a bone at the moment. Yeah, okay. Right, so I'm just trying to draw the picture here. Oh, flip. Straight lines are hard. Right. Okay, so there's the plane. So what do I tell you in the story? A ball is projected up an inclined plane as shown. The ball is launched at a speed of 50 and an angle of 60. So, and the plane is at an angle of 45. So this angle here, that's 45 degrees. Now, this one is projected at 60 degrees. So how big is this angle here? 15. Very good. Okay. So it goes up and it'll come down like that. Now here's the problem with this question. The ground, which is this thing here, that's at an angle. Oh, and by the way, let me just put in here, the G is down like this. Okay. Now, before I continue, can you all see that the problem is that the ground is at an angle, it's not flat? So what would be the easiest way to take care of that? Well, the easiest way to take care of that is to do this. Is to turn the picture. Turn the picture sideways so the ground is on the ground. Can you see what I did there? Yeah. Now, this actually makes a small little problem, because is the G pointing down in this picture? No. What's the G doing? It's pointing at an angle, isn't it? Yeah. So it's pointing down, but it's also pointing left. Okay? Oops. Now, the good news is that this angle here, it will be the same as this angle here. So this side here will be G cos 45, and this side here will be G sine 45.
What you see?
I can draw it for you in more detail. So I have a triangle here, and I have this here is the G, because this is parallel to this. Agreed? Yeah, you agree with that? So if I resolve like here and here, okay, this angle here is theta, that's 90. This is, what angle is this? This is 90 minus theta. So what angle is this? That one's theta. Yeah. So it means that that angle there is the same as that angle there. Alright. Okay, so let's resolve. So this piece here, this one will be 50 cos 15, and this piece here will be 50 sine 15. Now, if it helps you, you really, really want to think of this here as the x-axis, and then this one up here as the y. And it's the g that's a bit strange in this picture, because the g is heading at an angle. So, what do I want first? The time taken to reach the maximum height. So if I'm looking for the maximum height, should I look at the x or the y for maximum height?
Y.
The y. So u, v, a, t, s. What's the u? The u, you're thinking of the v, yeah. 50 sine 15. What's the v? That's 0. That's 0. For maximum height. What's the a? Yeah, it's minus g cos 45. There it is there. What's the t? Don't know. What's the s? That's what we want. What gives us the s here? What's v squared? V squared equals u squared plus 2a s. So the s will equal 50 sine 15 squared over 2g cos 45. That's the maximum height here above the ground. Yeah. So if you can calculate that.
And the time is what you want.
Is oh, sorry, I missed. What am I getting here? Oh, what is the time taken to reach maximum height? So I'll also need the t, yeah. Well, first let's get the s. So that's actually part B. That's part B. And A here will be the time. Well, what did you get there for S?
Not an error.
Oh, yeah, that's a problem, all right.
$12.07.
12.07 meters. Now, well, give me the t. I think I could just go with V equals U plus A T. So I can get the T is 50 sine 15 over G cos 45. That's for part A. That will be for the T. What's that, please? So I'll just put these numbers in red boxes. Huh? What's the T?
1.86.
Oh, 1.86. I thought you had 186. Like, it doesn't take 3 minutes to... yeah, 1.86, okay. C is next. Yeah? Continue. Continue, guys. Yeah. Okay. Well, what I want to do next now is get the time of flight. So that's the time to go from here to here. So should I look at the x or the y if I want the time to go from here to here?
Y.
So U, V, A, T, S. What's the U? It's 50 sine 15. What's the V? Don't know. What's the A? Minus G cos 45. What's the T? Don't know. It's what we want. But what's the S? 0. Because you're looking for it to go from the ground back down to the ground then. Right, so if I'm looking for the T, what formula should I use here? I should use S equals U T plus a half A T squared. Yeah? This is a quadratic. You can write it like this. A half G cos 45 T squared minus or plus minus 50 sine 15 T plus 0 equals 0. The reason I'm writing it like that is for people who want to use the formula, if you like. So this is the A, this is the B, and this is the C. You know the one you did in maths class? Yeah?
Yeah.
Yeah, you can do it other ways. So when you solve it, you'll end up getting T equals 50, 0 is one answer, 50 sine 15 over a half G cos 45 or 0 are the two answers. So obviously, which answer do we want? The first one. So for part C, let me know when you have the T there. Does anyone have the T for me there? Yeah, this thing here, 50 sine 15 over a half G cos 45. Should be something like nearly 3 seconds or something. 3.73 seconds. Yeah. Okay, part D now. I want to calculate the range. So if I go back to my picture, it means I want to know this distance here. So should I look at X or Y? Should I look at X? Now, it's not moving at a constant, it's not moving at a constant speed anymore, because there now is an acceleration in the X. Whereas previously there's usually no acceleration in the X, there now is an acceleration in the X because of this guy, the G sine 45. So we have to do it using UVATS. So what's the U? It's 50 cos 15. The V we don't know. The A is minus G sine 45. The T we don't know, and the S is what we want. Oh, sorry, the T we do know. It's 3.73. Okay, so well, give me the S here. I can just say S equals U, the heck, cos 15 u t plus a half a t squared. Okay, and that's it. So that gives me the range. You can let me know when you have that typed in, please. Have we got this range? Joe? No calculator?
Oh, we're going today.
Sounds believable. 140?
0.75.
It's a tiny bit off because my answer in the book is 131.
Yeah, 131.5.
Oh, okay. You must have mistyped something. 131?
Yeah, 0.9, that's what
Okay, good. Now, nearly there, guys. Part E. So for this last part, or nearly last part, what I want to know is when it hits into the ground here, it will have a velocity, a Vx and a Vy. And I want to know how much each is. So I actually have to look at both x and y. So I'll just put the x here and the y here. Okay, what's the u for this one? That's 50 cos 15. And the u here? 50 sine 15. The v here is what I want. The v here is what I want. The a here is minus g sine 45. And the a for this one is minus g cos 45. The t for this one is 3.73. The t for this one is 3.73. The s here I actually know. It's what was it? 131.9. And the s here I know it's 0. Because at the end it hits the ground. So if I look at all of this, what's the easiest equation I can use to get the v's here? Is it just going to be v equals u plus at? I think so, yeah. So here, v equals u plus a t. And here, v equals u plus a t. Right, so if you calculate those, you'll get 22.4 meters per second, I'm sure. And this one here will be minus 12.93. Why is that one minus? It's going down. Yeah, and why is the other one positive? It's heading to the right. Okay. F. How do I get the speed now from these two answers? How do I get the speed? So if I go back to my picture, this is the speed. How do I get that?
The square root
It's the square root, isn't it? The square root of what?
is 2.4 squared.
Yeah, plus 12.93 squared. And that would be 25.9 meters per second. And lastly, G is what's the angle here. So how can I get this angle? What would that be? It'd be tan inverse what? Tan inverse Vy over Vx, which we also know. So I worked it out just a moment ago. So that's tan inverse 12.93 over 22.4, which I think it must be roughly 30 degrees. Okay, it's a very hard question. Now the good news is they've only asked this question once in the last 10 years. So usually in the exam the question is more like, you know, number 1 or number 2. But once, you must feel bad for the students, they got a question like number 6.
How many marks?
It would be a full section B question, so it'd be 15 marks. No. It'd be 20 marks because you do 3 questions in section B. So it'd be 20 marks. Pretty hard question. I think the only other lesson that had questions as hard as this was maybe the weight and drag lesson. Who was asking me for this? Everybody?
I didn't even read the question.
You didn't like the look of it? Okay, what will we do next now? What do you need to see next? What lesson?
Newton's 3 law.
Is that earlier or later than projectiles? Newton's 3 laws, yeah, which one? 6. Ah, the weighing scales. Yes. Newton's 3 laws, question 6. Yeah? Can I do that, Siva? Yeah? Right. Ooh. Okay, question 6 is an interesting one. So, a man is in an elevator, and on the weighing scales, he stands, and the elevator moves up, and what it says his mass is, would it be? Yeah, well, he is 70, but when the elevator moves up, it will actually think he is heavier. than 70 when the elevator moves up. And when the elevator is moving down, it will say he's lighter than 70. So the question is, how much heavier will it say he is? So what do I tell you about the elevator? I tell you that it takes 4 seconds to move 5 meters. And we assume, of course, when you walk into an elevator, it's usually at rest. Right? You don't usually walk into an elevator that's already moving. So the U is 0, the V we don't know, the A we don't know, but we would like it. The T is 4, and the S is 5. So what will be the easiest one here to give me the A? S equals UT plus a half A T squared. Yeah? So that means 5 will equal 8A. So A is 0.625 meters per second squared. Is that okay so far? I'll pause for a minute to let you write this down. This is something which we'll need. Now, when we look at the man, how many forces are acting on the man in the elevator? 2, yeah. First one, the weight. And how much is that? 70 G. And what's the second one? The erection force. And his weight, which is 70 G. Which is bigger? Or are they not? Maybe they're equal.
The elevator is not moving?
Yeah, so when the elevator is moving, what's the story with them? R is bigger than W. Why? Because it's moving up. So the R must be bigger than the W. So what is the total force? The total force up will be R minus W. Okay? But Newton gave us a formula for total force. What's Newton's formula? F equals ma. So you get ma equals R minus W. Now, do we know the m? We do. Do we know the a? We do. Do we know the w? We do. It's only the r that we don't know. Okay, so let's work this out. So the m is 0.625, and the a is, and the m is 70, and that's equal to R minus, and what's the formula for weight? mg. So the m is 70, and the g is 9.81. So I can get R equals 0.625 times 70 plus 70 times 9.81. What's that, please? You got this? What's this calculated out as? These two added together, please. Should be pretty big, yeah. 730.45 newtons. Now let me just go to the left for one moment, guys, just over here for a moment. Let's pretend the elevator wasn't moving, so it's at rest. What's the story between R and W? Should be equal, very good. So the R should equal the W, which should equal 70 G, which is what, please? 70 G.
686.7.
600 and, sorry?
686.7.
Oh yeah, 686.7. If the elevator's not moving, that's what the OR should be, 686.7. But when the elevator is moving, it's not 686.7 newtons. This is what the OR should be if it's at rest. And this is what the OR is if it's moving. Can you see there's a difference here? Yeah. Let's calculate the percentage, what percentage difference that is. So if somebody could just do 730.45 minus 686.7 all over 686.7, and then once you get that answer multiplied by 100. So we'll just change as a percentage. %. Now, why is that important? This is why. A weighing scale doesn't measure your weight. It measures your reaction force, which is usually equal to your weight. For example, if this was a weighing scale and I put something on it, because it's not moving, the reaction force will equal the weight. And the weighing scale uses the reaction force to calculate the weight, because it figures the two are the same. But in this picture, the OR is not what it should be. It is 6% more. Therefore, the weighing scales will think the man has 6% more mass. So if you just take 70 kilograms and add on 6%, the quickest way to add on 6% to a number is just to multiply it by 1.06. That's how you can increase a number by 6%. It's a shortcut. If you didn't like that, you can just calculate 6% and add it on. 6 over 100 times the number. So what will this equal here? That is 74.5 kilograms. So simply by moving in the elevator, it thinks you're 4 kilograms heavier while moving.
And does this mean if it's moving downwards, it's 6% less?
I believe roughly so, yeah. Not exactly, but practically. You could test this out in the elevator, okay? You can get a weighing scales app on your phone. Okay, you can place the phone on the floor. You can put a weight on it. You can look at its mass. It'll say if it's something like this, it will say it's like 100 grams. A half a cup of coffee. Put it on the phone. It says it's 100 grams. Go up to the 4th floor, and you'll see it'll increase. Maybe it'll go to 105 grams. And then when the elevator stops, it'll go back down to 100 grams. You can test this out if you like. And then when the elevator goes down, it will go from 100 grams maybe down to 95 grams. Of course, its mass isn't changing. It's just the elevator is affecting the weighing scales.
I use the reaction force
Equals, yeah?
divided by 9.81.
Yeah, that's fine too, yeah. You mean the 730? Yeah. You kind of know this when you think about it, because do you ever stand in an elevator and then feel heavier as it's moving up?
Yeah.
Yeah, that's the same effect here. And when the elevator is moving down, you can feel lighter. Same reason. Okay, did you write that down? Got that? Yeah. Yep, got that? Okay. Right. I think we'll wrap it up there, so I will see you. No, not you. I'll see you at 2. Well, I think we'll use this room. Yeah. Yeah. No dentist appointment today, right?
No.
Anybody else I'm supposed to see at 2? No? No? Okay. Lunchtime.